I've got the heavy slinky stretched between me and Katie. I'm going to send a wave down towards her. She's going to try to keep her end steady as much as possible, a fixed end. And you see that whether she wants to or not, she's pulling down. When the wave gets to her, it pulls up on her hands, and by Newton's third law, she's going to pull down. So you see what happens is it gets reflected on the other side. We have what's called a phase inversion. It goes down as a crest, it comes back as a trough. And every single time I do it, it always gets reflected back on the opposite side. And if I keep doing it sort of random intervals, nothing interesting happens. But if I get it just the right frequency, it sort of settles in. This is what's known as a standing wave, because the pattern seems to stand still, almost like a jump rope, right? I'm still sending waves down, just I'm timing it just right, so that my waves going down that way are reflecting, or interfering with the reflections coming back towards me. We're interfering constructively in the middle, destructively where I'm holding and where she's holding. You notice that her hands are really not moving nearly as much because the waves are canceling each other out, what she's holding. That's what we call a node, where they cancel each other out. And my hand is another node, because the waves are canceling each other out here as well with destructive interference. In the middle, they're building up a larger amplitude. That's a position of constructive interference. And it all depends on what frequency I shake it at. The slinky already wants to vibrate at this frequency, so we say it is resonating with this. And so I'm just causing it to vibrate at the frequencies it already wants to vibrate at. If I double that frequency, I get the next standing wave. Now you see there are two locations where we have constructive interference, two antinodes. There are three nodes where I'm holding, where she's holding, and you look at the point in the middle, it's really not moving very much at all. It's another point of destructive interference, another node. So that's the second standing wave. If I triple the frequency, I get the third one. You see three places of constructive interference, three places where there are antinodes. If I quadruple the original frequency, ready? I can get the fourth standing wave. Four places of constructive interference, four antinodes.